right, so let's use some of those identities to simplify trigonometric expressions. So secant, that's 1 over cosine. Sine is just sine. Tan is sine over cosine. Well, I have a common denominator, so that's great. I can put those together. I'll get 1 minus sine squared x over cos x. 1 minus sine squared x, that's a rearrangement of my Pythagorean identity. So that's cos squared x over cos x, which of course just simplifies down to cosine of x. So this happens a lot. You need to be very comfortable seeing any form of this. So sine squared plus cos squared is 1. 1 minus sine squared is cos squared. 1 minus cos squared is sine squared. Cosecant squared minus cotan squared is 1. Tan squared is secant squared minus 1, etc., etc. So any rearrangement you need to be comfortable with. All right, so 1 over sine squared, I'm just going to leave that as 1 over sine squared. Tan squared is sine over cosine, but I've got 1 over tan squared, so I can rewrite that as cos squared x over sine squared x. Notice this one, I could have also started by saying that that was cotan. So that would have been another way to start. Common denominator and exact same principle. 1 minus cos squared, well, that's just sine squared over sine squared. So this one simplifies down to 1. All right, these are my even odd identities. I know sine of negative x is an odd function, so that's the same as negative sine of x. Cosine is even, so that's positive cosine of x. That simplifies down to negative tan of x. So another way we might phrase this is simplify each to a single expression. So we got down to just one thing. So that might be other things you see.